Once we understand the concept of a charged particle, we need to know how these charged particles will interact through electrostatic forces. And an electrostatic force is simply a push or a pull between two charged particles. There are two simple rules for electrostatic forces. If I have two particles with the same charge or like charges, they will repel each other, push away from each other. And conversely, if I have two particles with opposite charges, they will attract each other or pull together. Let's have a quick look at an example here. In system A, I can see two oppositely charged particles, and because they have opposite charges, they will attract each other. In system B, I have two particles with a positive charge, or like charges, therefore they will repel each other and push away. As well as these two simple rules, we also need to consider the factors that can affect the strength of an electrostatic force. The first factor that can affect the strength of an electrostatic force is the distance between particles. The closer together they are, the stronger the electrostatic force they will feel. The second factor is the magnitude of the charge on each particle, meaning whether it has 1, 2, 3, or maybe even 4 charges. And the greater the magnitude of the charge, the stronger the electrostatic forces will be felt. Let's consider the first factor in an example. In both system A and system B, we have two oppositely charged particles, so we'd expect to see an attractive force between them in both boxes. However, in system A, we have a greater distance between particles. And in system B, you can see the particles are much closer together. For this reason, in system A, we would expect to see a weaker attraction between them, and in system B, a much greater attraction between them. I've tried to represent the greater attraction with thicker arrows. Let's now have a look at an example for factor 2. In this example, both systems contain particles with negative charges, so I'd expect to see a repulsive force between them. And you'll notice that they are the same distance apart, but in system B, the particles have 2 negative charges each, as opposed to system A, where they only have 1. So, given that a greater charge magnitude equals stronger electrostatic forces, I would expect the particles in system B to be repelling each other much more strongly. As we move through the course in chemistry, you will consider more and more complex systems, and these can often involve multiple electrostatic forces occurring at the same time. Let's consider a system containing 2 hydrogen atoms. You can see for each atom we've got 1 proton in the nucleus with a positive charge and 1 electron in an energy level around the outside. So in this more complex system, let's consider the attractive and repulsive forces that are taking place. We know that attractive forces take place between oppositely charged particles, so I'd expect to see some attraction between the proton and electron in each atom, but also from the proton in one atom and the electron on a nearby atom. Something like that. In terms of repulsive forces, I'd need to consider charged particles with the same charge. So there's going to be some repulsion between the 2 electrons on nearby atoms, and also between the 2 protons in the nuclei on nearby atoms. So you can see that by looking at a more complex system, we need to constantly be thinking about all of these electrostatic forces that are taking place at the same time. And as you'll see on the video on potential energy, my system will eventually reach a stable state when we find a balance between the attractive forces and the repulsive forces. Let's now consider the key points from this video. Firstly, we need to know that electrostatic forces are pushes or pulls between charged particles. The 2 simple rules for identifying this force are that like charges repel and opposite charges attract. And there are 2 factors that can affect the strength of electrostatic forces. Firstly, the distance between particles. The closer they are, the stronger the forces will be. And secondly, the magnitude of the charge on each particle, where the greater the magnitudes, the greater the strength of the forces. If you are super keen and you want to know the mathematical relationship between these factors, you want to have a look at Coulomb's law. And that's it for electrostatic forces. Hopefully this video is of some help.